Hey, welcome to Unit 9. This is Lesson 9-1. We've made it to our last unit of the year, and I think there's about half a dozen or so of lessons here in Unit 9, so let's get started here. Systems of equations, graphing. Alright, today we're going to learn how to solve system of equations by graphing, and our vocabulary here, systems of linear equations and a solution of a system. Anytime you hear the word system, it simply means we're going to be dealing with more than one equation or one inequality. So we're going to end up with two equations that are sharing the same graph, the same region of space, something, and the solution of a system is going to have to satisfy both of the graphs, not just one of them, to be a solution of a system. Okay? So let's take a look. A system of linear equations are two or more linear equations containing the same variables like x and y. So here you've got 2/5 x minus y equals 0, and on the right you've got 3x minus y equals 13. So a solution to a system of linear equations is an ordered pair that solves both equations. So here's what we do. What we're going to do is consider an ordered pair such as 5, 2. And we're going to ask, is this a solution to the system? So just taking them one at a time. We know that from an ordered pair, this is the 5 is going to be x and the 2 is going to be y. Simply plug in what you know. I'm going to, because I have 2/5 as a coefficient, I'm going to write the x as a fraction. So I'm going to have 5 over 1. These 5's will now cancel, and it looks to me like 2 subtract 2 is indeed 0. So it's the ordered pair 5, 2 is going to work for the left-hand equation there. What about the right one though? Let's take a look at this one. Plug in a 5 for x and a 2 for y. 3 times 5 minus 2, does that equal 13? Well, 15 subtract 2 is indeed 13. Works for both, therefore it is a solution, not just to one equation and not just to the other, but in this case to the system of equations. Okay, so that's a solution. 5, 2 is a solution. Alright, take a look at this here. Does 1, 3 solve the following system of equations? 1, 3, the ordered pair 1, 3. So let's do the same thing. I'm going to plug in a 1 for x and a 3 for y. Look at that. 2 plus 3 is indeed 5. So it works for the left-hand equation. Let's try the next one. Negative 2x plus y equals 1. Negative 2 times 1 plus 3, does that equal 1? Negative 2. Yep, it indeed does work. So again, it works for both, so it is a solution. 1, 3 is a solution to this system. We're going to be given two equations. The same ordered pair works for both, so we're good. Alright, your turn. Is 2, 1 a solution for the following system? So you've got x plus 2y equals 4 as one equation, 3x plus y equals 6 as another. Plug in 2, 1 and see if it works. Let's see. So what do you think? If we plug in 2, 1 into x plus 2y equals 4, I'm going to end up with 2 plus 2 times 1 is indeed true. 2 plus 2 is 4, so it works for the left side. What about the right side? 3 times 2 plus 1 equals 6. Let's see, 3 times 2 is 6. 6 plus 1, well, that's not 6. So in this case, it fails on the second one. If it fails on one of the equations, it is not a solution to the system. So in our case, this one here, the answer is no. 2, 1 is not a solution to the system. It does not satisfy both equations. It's got to be both. Alright, now what about graphing? It says to find a solution of a system of linear equations, you need a point that each line has in common. In other words, where do the lines cross? So, if I have two functions like the blue one and the red one there at the top, if we were to graph these, there's the blue one, y equals 2x minus 1, and here is the red one, y equals negative x plus 2. Do you see where these two lines, of course, intersect? What's the ordered pair at which they intersect? Well, they intersect right there at 1, 1. So if you were to take 1, 1 and plug it into both of those equations, you would end up with two true statements. So you get two yeses there, and you would have a solution to your system. Alright, find a solution by graphing the two linear equations. So we've got y equals x and y equals negative 2x minus 3. So let's see what we got here. Find a solution. So on the left-hand side, I've got y equals negative 2x minus 3. So here's where we start. We start with the y-intercept. we have a slope. The y-intercept here is -3 with a slope of -2 on the left side. And on the right side, I've got y equals x. So y equals x. This means I've got a y-intercept of 0. That's agreed. With a slope of 1. So if we start here at the origin, we go over 1, up 1, over 1, up 1, over 1, up 1. Nice solid line there, nice and easy. What about the other one? It has a y-intercept of -3 and a slope of -2. Where do these two lines intersect? It looks like they intersect at -1, -1. So that should be the solution to the system. If we are asked to check, then we take -1, -1, and plug them in. So let's look at y equals x first. Is it true that -1 equals -1? Obviously that's true. So it does work for one of the equations. What about the other one? Well, it should work considering we just saw it on the graph. -2 times -1, well, that's +2. 2 subtract 3 is -1, so it works for both. So -1, -1 is a solution. It works for both of them. All right, find a solution by graphing the two linear equations. Let's try this one here. Y equals 1/3 x minus 3, and 2x plus y equals 4. Okay, so y equals 1/3 x minus 3 and 2x plus y equals 4. Looks like this is going to be the left-hand side one here. It crosses at -3, right down here at -3, with a slope of 1/3, which is up 1 over 3, up 1 over 3, and so on. So that's this one. Now, let's ignore that blue one and graph the next one over here. So if we graph this guy, I end up with a y-intercept of 4 and an x-intercept of 2. If you changed it to slope-intercept form, you're going to get the same thing. But what I did here was I plugged in a 0 for x, and I got y equals 4, put a dot here. Plug in a 0 for y, I got x equals 2, put a dot here, and connected the dots. If you change it to slope-intercept form, you're welcome to do so. Nonetheless, we end up with the same result. Where do those cross? At 3, -2. So if you take 3, -2 and plug it into your equations or your system, you are indeed going to end up with, let's see, a little bit of work here. The 3's are going to cancel, and I'm going to end up with 1 subtract 3, -2 is equal to -2, so that works. What about the other one? 2x plus y equals 4, 6 plus -2 is 4, and lo and behold, 4 equals 4, so we're good. All right, so again, the ordered pair there, 3, -2, it works for both, so we call that a solution to the system. All right, there is lesson 9-1. There's some more instruction there at the top and some practice there at the bottom. All right, we'll see you soon.